Thanks everybody for coming in. Good afternoon. I'll try to keep you guys awake, I promise. My name is Vic Parangelo. If you can't tell by the accent, I'm from New York. Anybody here in the room know Prosoft, use Prosoft? Show of hands or a nod? Yeah. So I put this presentation together because I'll give you a little bit of my background. So for the past, I don't know, I started in 1991 as a system integrator, building custom machines, upgrading machines, always dealing with different protocols, different manufacturers. So when I joined Prosoft 5 years ago, one thing I noticed is that when I'd ask somebody, even distributors, like, what does Prosoft do? And the answer I got was always about 25% of what we do. It wasn't like everything we do. So I put this together, this sort of 10-mile-high overview of Prosoft and what we do. If you break down the key applications that we work on, there are really 4, and I wrote them down here. So protocol converters, which is what everybody knows us for, protocol converters. But also phased modernization. I'm going to kind of show you guys what that is. Wireless Ethernet and secure remote access. These are the, so those last 3 are the kind of less known things that Prosoft does. So Prosoft's tagline is where automation connects. We were founded on protocol conversion. So you don't have to read this, but it's sort of a graphical breakdown of everything we do. Protocol converters, like I said. Phased modernization. This is when, as a system integrator, I always like to rip out the old stuff and put in all new. Sometimes it's just not feasible. So we have another solution for that. Wireless Ethernet. Basically, anywhere you can't or just don't want to use a physical Ethernet cable or a fiber optic cable. And secure remote access. I'm in New York, I build a machine, I ship it to Australia, get a phone call from Australia that says your machine's not working. Before I hop on an airplane to Australia, I can tap into the machine and access it as if I'm there. So I'll break it down for you, right? Protocol converters. This is not rocket science. Protocols are to machines as like languages are to people, right? And if protocols are a language, then Prosoft is Rosetta Stone, okay? Quick history, Prosoft, the founder of Prosoft, in 1988, he was working for Chevron, and he needed to get Modbus data into a PLC-2. So we have our roots in oil and gas, just because that's where he came from. So he cobbled together in his garage a gateway, and Prosoft was born. 32 years later, or whatever that is, we've got like over 40 different protocols in over like 200 different hardware combinations. By the way, you can see all of this stuff at my table. It's right across from the registration booth where you got your thing. So from a physical hardware standpoint of a protocol converter, we pretty much make 2 formats. By the way, anybody have questions, just interrupt me as I go. If you don't interrupt me, it'll take about 25 minutes. There's Rockwell in-chassis modules, right? So anybody know Control Logics, Compact Logics, right? These are the modules that snap into the backplane, okay? They're very nice. They tend to be expensive, but there's pros and cons of a in-chassis module versus a standalone gateway. This is a DIN rail mounted protocol converter. Sit on the DIN rail right next to the Compact Logics or Control Logics. It just doesn't plug into the backplane of the PLC. There's setup's easier with the in-chassis. Price is lower with the gateway. You got to run power to the gateway. You got to run cabling to the gateway. The in-chassis, you snap in, right? You could hot swap it. You could pop it out while everything's running. So there's sort of pros and cons to doing both. From a protocol conversion point of view, they're pretty much the same. So you want to go from Ethernet IP to Profibus to Modbus TCP to HART to DNP3, whatever. I think I skipped it. This is the product selector on the Prosoft website. You go in here, you hover over the word products, you say, you got to tell it whether you want a gateway style or in-chassis style, the green or the red, and then you come down and you say protocol 1 and protocol 2, right? And it'll take approximately 200 products and narrow it down to like 2. That's protocol conversion. That's what pretty much everybody knows us for. These other three, if I talk for half an hour on this overall thing, I have a deeper dive into each of these next three, where if we have time, I could do it. If you guys want to hear about it, we could talk about it later if you stop by my table. But modernization, phased modernization or phased migration, so everybody, just so I know you're still awake, lunch was good, nod if you know what any of these things are, right? Slicks, PLC 5s, 1336 drives, panel view classic, my all-time favorite, Flex IO on a obsolete Rockwell 1794 ASB adapter. So going back to when I was a system integrator, I noticed just out of working on hundreds of applications that there was always one of three choices for the end customer. First choice, rip it all out and replace it all new. That was my personal preference. It's what I always wanted to do, right? Sometimes you can't. Why? Budget, risk, downtime, lots of reasons not to do it. It's still running, don't fix it, right? The second most common approach was do nothing and pray, right? Until the distributor or the system integrator, like me, gets that 2 a.m. phone call that something went down and now you're sourcing parts on eBay, right? That's a very common one. I don't know if you guys agree or not, but. And the third option is phased migration, and this is where Prosoft comes in. So again, the idea of phased migration or phased modernization is you're not going to do a rip and replace, and you're not going to do nothing. You're going to phase out parts of the system. So if you look here, I've got a PLC 5 hooked up over Bluehost, right, Data Highway Plus or Remote I/O, to a 1336 drive or a Panel View Classic, or again, the Flex IO with the obsolete 1794 ASB adapter. The new stuff doesn't speak Data Highway Plus. You can't hook it up on Bluehost, right? So with this particular gateway that Prosoft has, it allows you to go from Bluehost to Ethernet IP, and you don't even have to touch the code in the PLC. The PLC doesn't know you did anything. It's still talking Bluehost, talking about Data Highway Plus or Remote I/O. But now you can put in your PowerFlex or your Panel View Plus or your 1794 AENT adapter, the Ethernet adapter, okay? So this is kind of like scenario one. You're changing the peripherals or leaving the PLC alone. You could do it the other way. You say, okay, well, what if I got this? I got a slick with all these remote I/O drops, and historically, this is a bitch to change, to modernize, to replace it. You can do the inverse. You can leave this alone. You can rip out the slick, put it in compact logics, and then when time and money permits, you can add a switch, and then you could start switching out the remote I/O drops. This is like, I call it textbook phase migration. You end up with this. Everything's new. You just did it on your pace, on your budget, with hopefully minimal risk. Okay. Another scenario, I call this historizing or bridging, but you've got a mix. You've got new networks in the building and you've got old networks, and the key here is these are working, right? You're not planning on modernizing them, but you want to get the data out of them, right? Your historian, factory talk, VT SCADA, whatever it is, you need that data. So you can bridge with that same gateway, you can bridge, right? So now your Logix or Studio, whatever it is up there, can reach down and talk here and pull data from here and vice versa. So on the topic of bridging or historizing, as I call it, this is what I run into like every day of the week. Somebody's got a functioning machine, it works, everything's great, but the historian can't see it, right? But if you're on any of these protocols on the legacy machine, DH45, DF1, ControlNet, DeviceNet, can't open, you can bridge it over to this, and now your MES or your historian can see it, right? And again, this is like you're not, in this case, you're not modernizing, you're just bridging to the data. And everything I just showed you was like legacy Rockwell to new Rockwell. You can do the same thing for legacy non-Rockwell to new Rockwell, right? So GE Genius, Reliance Automax, Texas Instruments 505, all these guys listed here. We've got these, all of this phase migration, this is like a special subset of protocol conversion, but it's geared towards specific manufacturers or legacy Rockwell product. So that's, like I said, that's phase migration. I have a deeper dive, a 30-minute deeper dive into monetization if you guys wanted to hear about it. The next one is industrial wireless Ethernet, okay? So from a portfolio point of view, I have this stuff at the table over there. We have a cellular unit or a industrial 802.11 ABGN 2.4, 5 gigahertz Wi-Fi. This is not the Wi-Fi in your house. This isn't Best Buy Wi-Fi. This is industrial hardened Wi-Fi, and I'll explain it. So basically, what is it, right? It's governed by 802.11. If you guys know Wi-Fi, anybody here an IT guy that knows Wi-Fi? Think of it like exactly what you have in your house. Just way more reliable, way more hardened with some hooks to Rockwell PLCs. But it's basically an edge enabler, and you'll see that in a couple of pictures coming up. Where or why would you use this? We sell it all over the place, okay? What I like to say is when you can't or just don't want to use an Ethernet cable or a fiber optic cable, like what you see in the picture. You can eliminate festooning cables in a crane. You can reach line of sight a mile or two. Mobile, anything mobile running around, you're not going to be tethered, right? So AGVs in a warehouse, amusement park rides, roller coasters, automotive facilities, mines, anything that spins. You guys know what a slip ring is? You can replace a slip ring with two radios. So this is the Prosoft radio, again, over on the table if you guys want to see it. I'm kind of a hands-on, like show and tell kind of guy. The nice thing about this radio is there's only really two versions. There's a IP20 version, which would live in like an enclosure. You get a cable come out to the wall, lightning arrestor, and then off to an antenna somewhere up on the roof. I just did an application in Manhattan, a hotel in Manhattan, not a hotel, hospital in Manhattan that had two buildings, one on either side of the FDR drive. They weren't going to tunnel under 200 yards of highway. They just put an antenna on each roof, staring at each other, done. The setup is so easy. It's so easy. I do it all the time. I sit at my desk at home, I take two radios or 10 or however many that the application has. I set them on my desk and I link them. Once I have them linked, you power them off, you bring them off to the site, put one there, point the antennas at each other, power them up. It's like you have a physical cable connected to them. 300 megabit per second. We'll have a new version coming out in the next couple of months, before the end of the year. If you guys don't know 802.11, it's A, B, G, and N. That's what our radios are. The next level is AC. It's 1 gigabit per second. We have add-on instructions, which is nice for if you're putting this with a Rockwell controller. By the way, this is not a very smart device. It's literally a cable replacement. It's controller agnostic. It doesn't care if it's hooked up to Rockwell or not. We just happen to have a lot of hooks into Rockwell. Add-on instructions, if you will. We also have this feature built in that nobody else has. It's really cool. It's called ultra-fast roaming. I'm going to explain to you what it is, but it solves a lot of people's problems that other radios can't solve. And then the other thing that's nice about it is there's really just one part number. It's the RLX2 radio. And when you get it, you configure it as either a master access point or a client or a repeater or a client repeater. So two typical broadband look at the types of applications. There's stationary and mobile. Stationary, like the hospital I talked about, nothing's moving. A couple of water towers talking to each other, passing information down a pipeline, anything in plant, like food and beverage or something like that, where nothing's really moving, but you just, instead of running Ethernet cable all over the plant ceiling, you just beam the signal across from room to room. It works like a mesh network. You guys know what that is? It's self-healing mesh. I got a picture coming up that shows that. So there's stationary and then there's mobile. And we really, there's nothing exciting about the stationary applications as far as I'm concerned, but the mobile stuff is really cool. And that's where the little bells and whistles that we have make us really exceed, especially if you're trying to do safety over wireless. Tough to do safety over wireless. We can do it. SIP safety, ProfiSafe over wireless. So we're all over the place. Thousands of our radios in Detroit. They're all over Disneyland. They're in all sorts of like Amazon distribution centers, Walmart, Target, U.S. Postal Service, these radios. So here's a sort of a breakdown of what the stationary looks like, right? You have this master control room with a radio, and then you have 1, 2, 3 clients. This could be a tank farm, right? This could be wastewater treatment with a bunch of clarifiers. So you notice here that this radio gets the signal from master by being bounced off of this guy. So this is a client and a repeater. It's a self-healing mesh, so if this radio blew up, this radio is smart enough to go either straight or go this way. And you can enable third-party mobile workers. So these guys are floating around with their laptops, and they're tapping into the, if you let them, they're tapping into the network. So a guy driving around a tank farm in his pickup truck doesn't even have to get out of his car. You tap into the network. Kind of looks like this. I talk about the wireless being an edge enabler, right? So if you think about it, our radios are never going to be in the enterprise. They're not Cisco. They're not going to be the Wi-Fi in this hotel. They're out more in the control network or out at the edge, right? So in this case here, you get a water clarifier with compact logic, point I/O, our radio, wireless, just like it was a cable or an fiber optic cable, to the control network with a switch. And this is what it looks like sort of on paper. This is what it looks like in real life, right? You got the SCADA lives here. SCADA lives in the building. It needs the data from all 12 of these clarifiers. You see it says out here that on each clarifier there's a micrologics, and the master control room has compact logics. They can all see each other, right? If sometimes instead of beaming straight back, they might beam off of one and then to the other. They decide that on their own. These guys had a choice. I'm going to ask you again in a second. These guys had a choice to trench out, like conduit, dig a blacktop, all this crap, all this stuff. Fiber optic. They were going to do fiber optic the whole thing. They deployed this in like 2 days. Wireless. No. The radios decide where it's going to go. I'm going to take half of that back. You can do unicast messaging instead of broadcast, if that's what you're talking about, where you can. It's Steam. Yeah. No, you don't.
So now you're talking. Where you're broadcasting information. Things going bouncing back. Oh, we got too much information. We can actually.
You can manage it.
Okay.
Yeah. And I'm going to stop right there because I don't want to make assumptions, but absolutely, yes. Because some of the things we talk about, so I have a deeper dive on wireless, just talked about wireless, and some of the do's and don'ts. One of it is manage your traffic. You don't want to just blast out everything all the time. So, no, that's fine. No, you're right. But then there's some other things like, security comes up a lot. So that we have a bunch of security features built in. It's WPA2 AES encrypted 256-bit. That's kind of standard. Like everybody has that, I think. But we have the secure bridging, which is where a Prosoft radio will only link to another Prosoft radio, so somebody can't like jump in. We have another feature called, not Air Marshal, rogue access point detection. So if you're on 2.4 gigahertz channel 6, this is a bandwidth thing, and you're doing fine, and all of a sudden somebody else is on that channel. It can flag you through an add-on instruction to tell the PLC to text somebody that somebody else is on that channel, right? May or may not be a problem. So that was the static stuff, but here's the mobile applications. This is where Prosoft really shines, right? So in a mobile application, if you guys are familiar with You guys know what roaming is? You know what roaming is, I'm assuming, right? If you look at this picture, this is all stationary. This is a backbone, right? And these access points, it could be, let's say it was this room, a distribution center, big Walmart distribution center, and you had a bunch of fixed access points kind of on the ceiling, and they're giving like a blanket coverage of Wi-Fi to the floor. And on the floor, you may have 2, 10, 100, 5,000 robots running around on the floor. That's what the red box is. So these are the bots, and they're moving around. Now, roaming, or I call it hopping sometimes, but roaming in Wi-Fi terms is, as this bot moves to the right, this radio is smart enough to know that the signal to this radio is getting weaker while this one's getting stronger. So at some point, and it decides, it's going to hop, it's going to roam. The problem is during the roam, there is a finite amount of time where comms are lost. You're not talking to either radio. You can think of it as like it's kind of jumping through the air, or I give the analogy of stare at your palm and blink. How long did you not see your palm while you blinked, right? 10 milliseconds, 50 milliseconds, I don't know. I get a lot of phone calls from people using brand X radios, and they'll say, we're having a problem, and I just ask the question, are you experiencing nuisance timeouts? A nuisance timeout is when a bot is running around, everything's doing fine, and it just stops. Now what happens is usually when you've got automated equipment running around the floor in close proximity with people, there's a safety protocol, right? SIP safety, Profi safe, whatever it might be. That safety protocol will send what's called a heartbeat out to the robot or whatever's moving. And it sends out a heartbeat and it has to get a response. This could be every 20 milliseconds, 50 milliseconds. You can kind of set it to what you want. But what happens is if it sends out a heartbeat and the radio is in the middle of a roam, our radio, anybody's radio, it's in the middle of a roam, it won't get a reply. It'll send out a second heartbeat, and if it doesn't get another reply, it shuts down the bot. That's the safety protocol. It has to do it. Somebody's got to reset it. Now, sometimes when you have 5,000 bots in a distribution center and one of them just shut down, it causes a physical traffic jam for all the other bots, right? So you're just losing productivity. And it's a silly thing because someone could go boop and turn it right back on. That does not happen with the Prosoft radio because we roam in less than 10 milliseconds. We roam more like 2 milliseconds. So we are like 10 times faster than the safety protocol. So it's not gonna, roaming will not be a reason for the nuisance timeout. I've replaced a lot of Aruba radios, some Siemens radios, specifically, they were doing fine, but they had these nuisance timeouts and we don't. That's it. Otherwise, the other guys are fine. Right? So I'll sum this one up. Last slide on industrial wireless Ethernet. Why would you use this? Why do you want to use this? It's so easy to deploy, right? Think of that water example. Trench out, lay conduit, shelving, trays, dig up blacktop, pull cable, or just go set up, good. It's not that easy, but it's very easy. Cost-wise, setup-wise, easy to deploy, and again, this is industrial hardened Wi-Fi. Okay. Quick list, I just thought of the top of my head of places where I've sold it. Right, tank farms, like I said, oil rigs, in plant, anything in plant. What I mean by that is, rule of thumb, it's a very fuzzy rule of thumb, under a mile, line of sight. You could see it less than a mile. It's in a warehouse. I could see it except for when it goes around a corner maybe, a beam might block it. We have these special antennas called MIMO antennas, M-I-M-O, multi-in, multi-out. They take advantage of the steel structure of, let's say, a building. So you could do a bank shot to the thing. So I don't have line of sight. You don't want to rely on that. It's that if it happens to be driving around a pillar, you can bank shot to it, but you don't want it to be sitting there stationary and just relying on the bank shot. You could put a repeater over there and then repeat, right, add a radio. But anyway, food and bottling, pharmaceutical beverage, bottle filling. This goes back to what I said about replacing slip rings. Very easy to do, except the power. You still need the power to go through a slip ring, but all the signals, Coca-Cola, Pepsi, They'll put a Compact Logix on top of the big fill ahead, if you've ever seen them, and the Compact Logix is spinning around, and there's a Prosoft radio spinning around with it, with like an omnidirectional antenna to another fixed antenna off to the side. It's doing the job of a slip ring, wireless. So the last one, and I have a separate, deeper dive into this one too, is secure remote access. Any of you guys use secure remote access at all? Secure remote access is, I live in New York, as you could tell from my voice. I build a machine and I ship it to Australia, and I get a phone call in the middle of the night, my night, from Australia that there's something wrong. Before I go buy airline tickets to Australia, I sit up in bed, I don't even get out of bed, and I flip open my laptop and I create a secure VPN tunnel on demand, and now my laptop is on their network. So I could break out Studio or whatever you guys use to, what?
Backdoor.
Backdoor? Yeah, it's pretty cool. So now, secure remote access to me is kind of a commodity. I can rattle off 5 companies that do it, Prosoft just being one of them. But there are 3 things that really separate Prosoft from all the other guys, right? We all do secure remote access, but Prosoft's got some security features the other guys don't have. I'll show you that. The other thing is that everybody does what I just described, on demand. I get that phone call from Australia. I created an on-demand secure VPN tunnel. I tunnel in, do what I got to do, and I get out on demand. Everybody does that. It's great. Prosoft, in addition to that, with the same hardware, can do an always-on connection. Completely different application, same hardware. So here's on demand, right? Like I just described. I'm in New York, I get the phone call from Australia, I tunnel in before I go fly to Australia to try to fix it. It's pretty straightforward. That's on demand. Here's the always on. Imagine you have 2, 10, 200 sites scattered around the city, the county, around the state, around the country, around the world. It doesn't matter where they are. I can have them all connected all the time, like a mesh network, where the cloud is the switch, a layer 2 switch in the cloud. We call it Prosoft Connect. The always on portion of it is called PDN, Persistent Data Network. The reason why I wear that jacket is because I'm always in water utilities, because they buy it all the time. They're replacing lease line modems, copper wire, RF, whatever they've got, with this. So the SCADA, oh, here's an example. Again, the SCADA lives at the treatment plant. In this case, it was a 96 site application. It could be 2. This was 96. The treatment plant, where the SCADA lives, the SCADA wants to see all 95 remote sites. They're scattered in the mountains. So we have these devices out there at all the pump stations, lift stations, water towers, whatever the assets are that they need to have access to, that the SCADA needs permanent connection to. Because I think what they were doing before is they were polling one, disconnecting, polling one, disconnecting, polling one, and it took them like 10, 15 minutes to get around to poll the first one again. However long it took them to poll 95 sites. This way, they see all 95 all the time. It's like, I'm oversimplifying this, but it's like all 95 sites are right on this table, all connected to the same switch. But the switch is in the cloud. The hardware to do this is the same whether you do the on-demand connection or the always-on connection. It's the same hardware. There's a cellular unit or a network bridge. There's a wired unit. So both of these have a WAN and a LAN. The WAN here is you plug it into your local internet. The LAN is, the PLC. And on the cellular one, the LAN is also the PLC, but the WAN, in that case, is cellular. It can be a mix, AT&T, Verizon, mobile, the system doesn't care. So, here's the fun part. Every time I'm dragged into an application, it's always the same, exact same discussion with the same two people, the OT guy and the IT guy. Right? Different discussions, same discussion, right? So the OT guy has his KPIs and what he wants, and the IT guy has his issues, right? Yeah. So I'll just pop these up here and walk through them pretty quick. So the OT guy, he's pretty easy, right? He wants more bandwidth than what he has. He wants it, very reliable. It's always up. He wants to be able to access his system from his yacht or bass boat, whatever he has, right? Did I miss one? Yeah. He wants someone else to handle the login. He's not an IT guy. He just wants better than what he has now. He's easy. This is a completely different conversation. He wants security. As a matter of fact, he doesn't even want this in at all. He doesn't like it. So Prosoft does something called defense in depth, right? So we have multiple layers of security to try to address every concern this guy has. And we've got two that nobody else has, meaning the other guys that make secure remote access. So if I walk around it really quick, two-factor authentication, token-based, not a big deal. I mean, it's a big deal. Other guys have it too. IP whitelisting, that's when the gateway is hooked up to 5 devices with 5 IP addresses, but it'll only let you see 2 of them. You whitelist what you can see or can't see, right? So when I tunnel in, I can't see all 5. I can only see whatever it lets me see. Single sign-on, this is big. You guys know what single sign-on is? SAML 2.0, Microsoft Active Directory. Nobody has this but Prosoft as a security feature. Single sign-on is when you use your corporate credentials to log in. What does that mean? IT owns it. So in my case at Prosoft, right? When I got hired, they gave me a username and a password. I could see the HR portal. I could look at my W-2 or whatever it is. If I quit, they cut me off. If I get fired, they cut me off. That's single sign-on. IT likes that. Because otherwise, if it's in OT's hands and the guy quits or gets fired, they might not cut him off, like forget to cut him off or whatever. These guys own it. They like that. 256-bit encryption, again, pretty much industry standard. Single-use credentials, that's pretty big. Every time you tunnel in, it creates a custom random generated password. It's only valid for that session, so I can't give it to you to use. You can't pass it around for it. It's for me, that time only. That's pretty big. There's no software to install or maintain. This is very big. All you need to have this work is you create a Prosoft Connect account, which is free. You go to prosoft.io, you type in your email address and a password, you've just created an account. And now, from that point on, anytime you want to use the system, you could be anywhere on anybody's web. You just need a web browser. From that point on, you just need a web browser. There's no software to maintain. If we do patches, we manage it. We manage everything behind the scenes. You do not need to be an OT guy. You do not need to purchase an expensive server. You don't have to know anything. We do all the heavy lifting behind the scenes. It's very easy. We call it simple, safe, and secure. Independent pen testing. We pay people to hack it. They hack it, we fix it. Detailed audit trail. You go in, anytime you go into the system, you can see a log of all the event history. I go in there and I see, okay, Vic went in there at 2 o'clock this morning. He accessed these devices. He logged out at 3:05. The next morning, everything's broken, and they look at the data log. Well, Vic was in there at 3 in the morning, right? So there's a detailed audit trail of who's been in there. But this is crazy good. Virtual lockout tagout. We made up the name, vLotto. It gives somebody, usually the IT guy, overall administrative rights to police access to the system. So here's a common complaint from IT. I build a machine, I sell it to you, you're his IT guy. You don't like the fact that anytime I feel like it, I might tunnel into that machine on a whim to check it out, to do a firmware upgrade. You don't like it. So you become the gatekeeper. You hold the keys. Anytime I try to tunnel in, you're going to get an email. It says, Vic's trying to get in. He wants to get in at this time for this long. He wants to see these IP addresses, and here's why he's going in. I'm not getting in without you approving it. Every time. Every time I try to connect, you're going to get notified I'm trying to connect. You can come back and you can say, yes, you can go in, or no, you can't go in. And when you say yes, you could say, yes, you can go in, but you can only see this IP address, not the 5 you asked for. You can only see this one. So you can whitelist per connection just that device, right? And you can't be in for 2 hours. You can be in for 15 minutes. And oh, by the way, while you're in there, he can kick me out anytime he wants after he let me in. Now, there can be multiples of him. Maybe he's on PTO. He's sick that day, right? So 3 of you guys, every time I try to tunnel in, 3 guys get notified. If any one of you says yes from your phone in your email, yes. Anybody says yes, I'm in. Anybody says no, the no's trump the yes. And again, a yes first and I get in, and then a no later kicks me right out. That usually is very attractive to the IT guys. So they have the single sign-on where they own the credentials, and they have the virtual lockout tagout where no one's getting in without them approving it. And they can modify the access permission if they do let them in. So that's it for the overall discussion. If you guys have any questions, I can talk about them, or if you want, we have 25 minutes left. I could do a deeper dive if you want. We could do a deeper dive into modernization, a deeper dive into wireless, or a deeper dive into remote access. Or we could just break. It's up to you guys. I'm happy to do a deeper dive if you want, or just talk general stuff. I have something else that I didn't put up there.
So you're saying up to 1,500 feet
Of what?
of communications
For
for your,
the wireless?
yeah, for your wireless.
A mile, 5,000 feet.
5,000, wow, that's pretty good.
You know what? It's a fuzzy number because are you passing through anything? Is it perfect line of sight? Are you going through trees?
That's my question.
Look, so here's the thing.
Like a SCADA system at a plant,
Yeah.
okay? And you're going out to your different, like you said, clarifiers or out to pump stations or whatever.
Mm-hmm.
So you're going through, you have an area where you put one outside. You can hit anything up to 5,000 feet or something.
About. There's certain things start to decay, right? Like at 5,000 feet, maybe you're not going to get 300 megabit per second, right? Maybe you're going to get 50 megabits per second, which may or may not be okay. You know, what I tend to do. So, you guys, any of you guys know what 900 megahertz frequency hoppers are? That's the older technology. It's still used, but 900 megahertz frequency hoppers, esteem. We just discontinued them 2 years ago. They've got pretty good penetration, right? They'll go through walls, they'll go through trees with leaves, they'll go 10 miles, but they're serial, they're slow. So they do the job if that's what you need, but if you're going to hang a compact Logix on it and try to pump data through it, you're not going to get 300 megabits per second, you know?
So if say we had something down in the valley and a lot of our operations is going on at the top of the mountain, but it's a ways away. Can you put a repeater at the top and bounce it off from the bottom of the valley?
You can, but the first thing I would do is walk down into the valley with my cell phone and see if there's a cell signal. It's a lot simpler, just do it that way. You could do it either way, but you know, so this just happened. There is cell service. If there's like one bar, we have over 100 different antennas. And if there's like one bar without one of our antennas, we'll get you to like 5 bars. Like a Yagi pointing where you know the tower is over there, but you can't see it, take a Yagi, point it that way. Now that one bar just became 4, you know, or whatever it might be. What was I going to say? A lot of times I get phone calls, people they have 900 megahertz frequency hoppers, they're big in water, wastewater, and they're looking to just upgrade, replace it, do it new. And I'm like, look, we discontinued them, here's why. They're slow, they're unreliable, they're serial, you know. That's the key, right. The distributors are like, I don't even sell something that's serial.
That's what's one of the problems. Yeah. So now we got to go with like, you know, compact Logix or whatever, and they discontinued like the L32 that had the serial port. Now you have to use like a Prosoft serial adapter, right? And then there's some configuration and stuff that you're going to have to go through, and like it's become, you know, anything that you can do, Ethernet or whatever, it's got to be better.
So here's the trade-off, right? So you can use the Prosoft radio under a mile-ish. But okay, well, what about beyond a mile? PDN, what I just described, the PDN, the cellular. I don't know why that keeps coming up.
Mix that, like,
Yes.
so you can go cellular, you can go your, let's say, wireless Ethernet or whatever to the cloud.
Mm-hmm.
And
I don't know why I keep getting that picture, but there's something else I wanted to show you. It's a little off topic, but it's kind of cool. We make something called a data logger. It's kind of doesn't fall into any of those categories, but it's pretty cool. And if this data logger. So here's what the data logger is. A little DIN rail mounted device. I have one over at the table. What it does is it can record. You hang it off a PLC. It can record up to 17 million time-stamped records, 200 tags. You know it?
yeah, I'm familiar with it
Okay.
somewhat.
As fast as 50 milliseconds frequency, so 20 recordings per second. You could slow it down. It doesn't have to be that fast. It has 3 uses. Where I sell it, I see 3 use cases. It's number 1, it is a poor man's historian. It is a poor man's historian. It is not a historian. It's $1,000. It is not OSI Pi. It is not Factory Talk. It's a data logger. But it's $1,000, and you can record a ton of data with it.
Right.
People ask me, how long does it take to fill up the memory? It depends. If you're recording 200 tags at 50 millisecond increments, it takes about an hour and a half. If, typical water application, where you're recording once a minute and like 10, 20 tags, it takes like 1,000 years.
Yeah, we were looking at something like that, where they were just going to kind of record, so many data points. They weren't going to record everything, and then it was going to take up some time.
Yeah.
But I can't remember how was that data extracted? Excel, what was it? CSV file.
It's a CSV file.
I couldn't remember. Yeah.
It's a CSV file, but
CSV, you can export it through Excel, right?
Yeah.
okay. So I wish this would come up. I have these great answers to your questions in picture form.
We just
Son of a
like your-
bitch. Okay.
I spent a week and a half in New York here not long ago, so I'm trained in the year.
I'm sorry, by the way, about the Penguins. I'm sorry.
No, I'm going up. I love them. I was pumped.
You were pumped?
He's anti-Pittsburgh.
Matter of fact, when they started scoring, I started texting a bunch of group messages and got kicked out of a lot of them.
As well you should have.
So here's the deal. We make 2 data loggers to answer somebody's question. I'm sorry. Oh, your question. The standard data logger and the data logger plus. Here's what they have in common. They both have the same logging capacity. They can both do 16.7 million timestamp records. They can both record up to 200 tags simultaneously as fast as 50 milliseconds, 20 times per second. Both of them can do that. The difference is the standard data logger, you have to walk up to it with a laptop and an RS-232 cable and extract a CSV file. With the Plus, you have some options. It has its own web page. It has its own IP address, okay? Now, you can remote into it. You can kind of trend the data.
Can you put it on the network?
Yeah. You can put it on the network. You can have it remote, where you can, what I was just talking about, remote access. And it's also, do you guys know the company SciTech? They make something called Excel Reporter.
Yeah.
They have a driver. They have a connector to the Data Logger Plus. So it hooks right into that. So bare bones, you walk up to it and pull out the data, or you trend the data out, or you write a REST API and pull the data, or you buy Excel Reporter and it'll pull the data. And then it puts it in so many pretty display, which again, I can't right in front of me here. There's 3 typical use cases for it that I see the most. The first one is poor man's historian, right? I got distributors up and down the East Coast. They package it into a box and they say, look, it's not a historian, but it'll kind of do sort of what you want. The other thing is forensic analysis, right? So you got a machine running. You come in the morning and it shit the bed, and you go check out the data logger from last night, 11 o'clock to 3 a.m. And now you can look over the data, see what happened, right? I call it forensic analysis. And then, I guess there's 4. The other one is it's a cheap insurance policy for filling in holes in data. So for instance, in the water applications, when you have remote sites, American Water, Suez, Aqua, these guys buy hundreds of these at a time from us. And when they upgrade a pump station, a lift station, and they put in a new controller, if they're not using DNP3, they put a data logger there. And then basically what they're doing is they're hedging against the EPA. So if the comms go down to a site for whatever reason, for an hour or a day or a week, when the comms come back up, they just reach into that data and say, give me the last 3 days worth of data. And they backfill their missing data. So they don't have to go to the EPA with their data and say, well, we don't know, we have nothing from these 3 days, right? So it's pretty cool. It's really cheap. I mean, $1,000. Not a historian, but for people that aren't ready for a full-blown $15,000 historian, if you just want to get your feet wet, and it logs right at the machine, and you set it up. You set it up to how fast, how many tags, how you want the data. I got 10 minutes if you guys got any questions. Otherwise, feel free anytime from now till stop by my table. It is. In the search, you can either type data logger or you can type in, the part number is PLX51-DL plus for data logger plus. And I'm staring at a picture of it. Not up there. You can hang it up. One unit you can tie to up to 3 PLCs. So you don't need one per PLC. You can have one tapping 3 PLCs, data coming out of 3 PLCs, up to 3 PLCs. And you program it. You say like, oh, okay, what happens if I do fill up the buffer? You can tell it what you want. You could do FIFO, right? You get to the very end and you just start overwriting the old data. Or you could have it wipe the entire thing and start rewriting. You could have it record on exception, meaning if a value is 10 and it just stays there at 10 and you don't want to record 10, 10, 10, 10, 10, you could just have it record only when it changes. Set a dead band, like if it goes over 12 or under 8, start recording. If it's sitting in the dead band, don't record it. It's
I would assume there's multiple protocols that they could talk to in that regard, which not.
Oh, good question.
No, it just can't talk to Alan Bradley. It can talk to multiple protocols. I would assume.
I completely forgot to mention that. Ethernet IP, Modbus serial, Modbus TCP/IP, or DF1 serial. That's it. So 4. I never. Hmm? No, but like he just said, we have a Profinet or Profibus to Ethernet IP, and then you could go into data logger. But we Prosoft generally frown on what we call the 2 gateway solution. It can be done, but you're going to go from Profinet convert to Ethernet IP just to bring it into the data logger. Well, that would work. That's not really yeah, you can do that. I'm going to put a little asterisk on that, like, let's check with tech support. But yeah. So, the biggest thing I see, look, the wireless is huge. The remote access, not so much the remote access, but the PDN, the always-on connection, that's pretty big. And that's why I walk around with this jacket, because after my second wastewater utility and the loaner jacket they gave me, which was a little skanky, I went and bought my own jacket, but I'm in there all the time. And the modernization's big. But quick funny story for you guys, true story, funny as hell. I was up in Canada, And there was this candy factory run by the original founders of the factory, a man and his wife, in their like late 80s. And everything in the place was just old, right? All the technology was, state of the art 1950. It was working. So these guys, prior to me going there, they hired a consultant to tell them, how to improve their operation. And the consultant spent a few days in there, and then he said, okay, you need to upgrade all this stuff, like step into the 1990s at least. So they fired him. They brought in another consultant, and same thing. What can we do to improve our OEE, operational efficiency? And he studied everything they had, and he said, you got to get new stuff. And they fired him. And then a couple days later, in the middle of the night, the entire plant went down. So they fired the maintenance supervisor. That's the joke. That's right there. This really happened. I bring this up because when it comes to modernization, people are right there hanging on. You guys know this, I'm sure. That just people are hanging on to the old stuff because it's working. But if there are applications where, like I kind of showed in the modernization part, if you're not going to rip and replace it, and I have a bunch of distributors up and down the East Coast that's all they'll do. They don't want to talk about anything but a rip and replace. But if you got a quote for a complete rip and replace and you're doing nothing, you have this phased approach as an option. That's all. At the end of the day, you're going to modernize anything anyway, and you'll probably spend more money if you do it in phases because now you're buying these intermediate products, but it takes away a lot of the risk. And sometimes you could also do it on your OpEx budget instead of your CapEx budget, right? You're not going to go out and spend $100,000, rip everything out. You're going to spend 10 and just change some drives. So that's it. That's the gist of it. Like I said, I'm at the table over by the registration booth if you guys have any questions. And thanks for staying awake.